Okay, fine. So note down the next question. So the question is, in how many ways 3 boys and 3 girls? Students, everyone are noting it down, right?
Yes, sir.
Yeah, in how many ways 3 boys and 3 girls can be arranged in a row containing 6 seats? In a row containing 6 seats, such that no 2 boys and no 2 girls sit together. I'll repeat the condition, such that no 2 boys and no 2 girls sit together. Solve it, tell me the answer, man. Is any answer, students?
The answer can be 3 factorial into 3 factorial, sir.
You're almost correct, but still that is not the right answer. Just check it out. You missed one part.
Sir, 3 factorial into 2 factorial into 1 factorial 2 times.
No, ma, check it out.
Sir, 3 factorial into 3 factorial into 2 factorial into 2 factorial into 1 factorial into 1 factorial.
No, ma, wrong, ma, check it out. It's not 3 factorial, 2 factorial.
So 3 factorial. 3 factorial into 3 factorial into 6p3.
Why 6p3 suddenly? No, check it out.
2 into 3 factorial into 3 factorial.
Yeah, correct. Good. Can you explain how, ma?
Like the girls, like the 6 seats are there, so no two boys and girls should sit together, so it will be like alternate ways. And this, like the girls can be arranged in 3 factorial ways and 3 factorial.
Okay. Okay, fine. So let me explain it. Listen carefully, ma. So according to the data, what they have given here is so. Let me share the screen. Text. So you'll be having first pace followed by second, third, fourth, fifth, sixth. So what will happen here is arrangement can be boy girl, boy girl, boy girl, or it can be girl boy, girl boy, girl boy. So here each and everything has an arrangement of 3 into 3 into 2 into 2 into 1 into 1. So this gives me a total value of 3 factorial. Ma, is this
Yes, sir. 3 factorial into 3 factorial.
is it recording, ma? Can anyone tell me whether it is session is recording or not? Yeah, okay. So 3 factorial into 3 factorial. So this is for the first arrangement, that is for boy girl arrangement. The same thing you can expect for the second set, that is 3 into 3 into 2 into 2 into 1 into 1. So I'll be having another 3 factorial into 3 factorial. So you can write totally together as 2 times of 3 factorial into 2 factorial. Sorry, 3 factorial into 3 factorial. Is that clear?
Yes, sir.
Okay, fine. So note down the next question. So the next question is, let us say you have in how okay, so the question is, in how many ways the word orbit can be arranged? I'll repeat the question. In how many ways the word orbit can be arranged such that the vowels are always together? I'll repeat it. Such that the vowels are always together. Just think and tell me, ma.
So 2 factorial into 3 factorial.
2 factorial into 3 factorial. Just think and tell.
Four factorial, sir.
Come on, man. 4 factorial.
Sir, 3 into 2 factorial into 3 factorial.
3 into
2 factorial into 3 factorial.
3 into 2 factorial, 3 factorial. No, man. Just check it out.
4 factorial. Sir, 4 factorial.
4 factorial. You didn't complete it.
Like 4 factorial ways.
Yeah, 4 factorial is a part of the answer. What about the other part?
Can be arranged. Okay. 4 factorial into 2 factorial.
Yeah, good. What about others? Okay, so now listen carefully, ma. Okay, so now according to the question, what they have given here is, I think one student is waiting. Kishore. Okay, so now listen, ma. So according to the data, what we are going to do is, text. Okay, so now what we are going to do is O or BIT. In this, vowels are together, which means O and I will be together. So I'll consider this as one single group. So I'll take these two as one item. Remaining, what are the things present? R, B, E. So these are considered as 3 items. So totally how many are there, ma? 4 items. 4 items can be arranged in how many ways? They can be arranged in 4 factorial ways into OI can interchange among themselves. So it is 2 factorial. So I'll write the reason on the side. So OI or IO. O comma I or I comma O. Any doubt in this question, students? So my answer will be 24 into 2, 48. Is that clear?
Yes, sir.
Okay, ma. So note down it. I'll give the next set of questions. Okay, so the next question is nothing but let us say you have 10 points, 10 distinct points. So how many line segments can be formed? This is my question. So listen to the question carefully. In how many ways or how many different line segments can be formed using 10 distinct points plotted on the graph? Is that clear, students, everyone? Yes, are you there on the line? Hello.
Sir, not clear, sir.
See how many line segments can be formed using 10 distinct points that are plotted on the graph. So this is nothing but your combination question. It is not arrangement question, it is combination, because you have to select how many line segments can be formed. That is the question. So think and solve.
Sir, can it be 10 factorial into 5 factorial?
Why 10 factorial into 5 factorial suddenly? See, I told you it is purely a combination question. Combination is nothing but selection. So how to solve this question in terms of combination is, listen carefully. So the question is asking you how many line segments can be formed using 10 distinct points. First of all, for forming a line segment, how many points you require? Two
Two
points are
points.
required to form a line segment. So how many points you have? You have 10 points. So
10
10
points, 10C2.
C2. When you expand 10 C2, it is nothing but 10 factorial divided by 8 factorial into 2 factorial. It is nothing but 10 into 9 whole divided by, I'll just write it here. So 10 into 9 the whole divided by
2.
2 into 1. So we know it is nothing but 45. So my answer is 45 line segments can be formed. Is that clear?
Yes, sir.
The same thing if I ask you how many triangles can be formed, then what will be your answer?
10C3.
NC3.
Yeah, what is the value of 10C3?
10 into 9 to 8 divided by 6. $120, sir.
Okay. Okay, any doubt till this, ma'am? Others?
No doubt, sir.
Okay, fine. So the next question is nothing but, let us say you have a totally 12 chairs. Okay, so 12 chairs which are placed next to each other. So there are 5 Indians and then 6 or 5 Americans, and then you have two, African people. So the question is, In how many different ways they can be arranged in those 12 chairs such that same people of same countries sit together? I'll repeat the question. There are 12 chairs, 5 Indians, 5 American and 2 Africans who are waiting outside. In how many different ways they can be arranged such that the people of same group sit together? Is that clear, students?
Yes, sir.
Okay, so think and solve.
Sir, 12C5 into 7C5 into 2C2.
Come on, man. Why 12C5? See, whenever you're using combination, ensure that you don't use it randomly. 12C5 means out of 12 people, I'll be selecting 5 people. That is entirely different with respect to this question.
Permutation also.
Good.
So 5P2 into 5P2 into 2P2.
Come on, man. Why you people are getting confused with this much?
Like 2 nationalities should be together of same country, no, sir?
See, listen. According to the data, you have 12 chairs and 3 different groups are there. I can make it as Indian, American, African. So let me put this as capital A. Okay, so that to differentiate it. So it can be like this, or it can be AIA, or it can be AAI, or any other form is there. Yeah, it can be I followed by capital A, then small a, or it can be small a, capital A and I, or it can be small a, I and capital A. Any doubt in these 6 arrangements, ma? So these 6 arrangements, if you take the first arrangement, 5 Indians can be arranged in 5 factorial ways among themselves into 5 Americans can be arranged in 5 factorial ways among themselves into 2 African can be arranged in 2 factorial way among themselves. Same thing will be there, but order will be different. That is,
6 times.
yeah. So 2 factorial into 5 factorial into 5 factorial. So the same process gets repeated for 6 times. So my answer will be what? 6 factorial. So let me write it on the top. My answer will be 6 factorial into, sorry, 3 factorial for all the 3 people arrangement. 6 into 5 factorial for Indian, 5 factorial for American, 2 factorial for African. So this is my final answer. Any doubt in this question, students? Yes or no? Any doubts?
No doubt, sir. Noting it down, sir.
Okay, note it down. Is completed?
Yes, sir.
Okay, so note down one more question. So the question is, in how many ways 3 boys and 4 girls can be arranged in a row? 3 boys and 4 girls can be arranged in a row containing 7 seats, such that men occupy only odd number seats. Such that men occupy only odd number seats. Think and solve, ma. Hope everyone are clear with this question, right?
So only odd number of seats then.
Men occupy only odd number seats.
Okay.
When I go, third grade, 40 to
Is any answer, students?
Or 2 factorial into 3 factorial into 4 factorial.
3 factorial into
3 factorial into 4 factorial into 2 factorial.
check it out, man.